All right, I come into a patient's room and I see that I'm in pressure control, assist control, or assist control, pressure control. I see that I got a set rate of 10, inspiratory pressure 18, and I time at 1, PEEP of 5. My flow trigger's there at 0.1 and 21%. I happen to look at not only the color of those ventilator graphics, but I also see that my set rate is 10 and my total rate is 16. Let's pretend for all intents and purposes, let's say that this patient is intubated, obviously mechanically ventilated, and they've been given a paralytic. So whether it was succinylcholine, vecuronium, pancuronium, cisatricurium, whichever, they've gotten some type of paralytic, whether it was a depolarizing or non-depolarizing agent, they've been paralyzed. So if they're paralyzed, that means that they should not be breathing any above that set rate. And you can also tell that there is no electronics hooked up to this test lung that I have set here. There's zero electronics, so it has no ability to spontaneously breathe on its own. But yet if I come back over here to the machine, we will see that I have a set respiratory rate of 10. So looking at that and an I time of 1, 10 into 60 gives me 6 seconds. So I've got a 6-second total cycle time. So that inspiratory time set at 1 second is there. So that means out of 6 seconds, 1 second is spent in inhalation. The other 5 seconds are spent in exhalation. As respiratory rate goes up, total cycle time is going to go down. So that means, and if we keep our inspiratory time constant at 1 second, the shorter the cycle time gets, that's the less time you have for exhalation. So if this trigger is set too sensitive, the patient could go into a situation where we'll call it auto cycling or auto triggering the ventilator, where the ventilator is set too sensitive so it fires more breaths on top of what the set rate is. And if it gets up too high, you could definitely get into a situation where we air trap, breath stack, or however you want to look at that, where you basically are given too much of an not enough time to exhale the volume that went into the chest. So look here, my set respiratory rate is 16. Well, I know that a normal flow trigger for a patient should be 1 to 3 liters per minute, or I could do a pressure trigger, and that could be -1 to -3 centimeters of water pressure. So with this, basically what this means is my machine is set too sensitive. So the patient is now triggered a 17th breath when I have a 10 breath. And we just said that the patient was paralyzed, but in this case, that has no ability to spontaneously breathe on its own. So being well trained in all things mechanical ventilation, I know that if I come over here and say, I must be autocycling. And the deal is, under normal circumstances, and just because I've been playing with it a little bit before turning this video on, I know that at a rate of 10, inspiratory pressure of 18, PEEP 5, that my exhaled tidal volume should be in the ballpark of about 0.28 or 0.29. Which those exhaled tidal volumes, because in assist control, pressure control, even though these are patient triggered, they're still mandatory, controlled, or ventilator breaths that are being delivered. So in this case, the patient's saying, hey, I want more of what you got. Please give me more of what you got. But in this case, the patient's not really saying that. It's given more of what it's got because the flow trigger is set inappropriately. But the point that I'm getting at is, let's assume that at a rate of 10, without any additional breaths over that, my minute ventilation is going to be roughly 2.8 liters, 2.9 liters in that ballpark, depending upon what the tidal volume is, because respiratory rate times tidal volume equals minute ventilation. So let's say that under those circumstances, my blood gas was perfect for the patient. 740, 40, 90, 24, as far as pH, PaCO2, PaO2, and bicarb. Now, because somebody come in and inadvertently changed my flow setting and made it too sensitive, that minute ventilation went from 2.8 or 2.9, it doubled. So if my ventilation doubled and that ventilation made it down to the alveoli, the effective portion of your ventilation, then we removed that much more CO2. So there's a decent chance I went from a perfect looking blood gas to now an iatrogenically induced respiratory alkalosis. So iatrogenic means that we may have done it, and in this case we did it because of an inappropriately set flow trigger. So if I take this and I take it to 1, make it a little more difficult for that test lung to trigger, we're going to go back to the monitor now, and we're going to notice that the color of those waveforms changed. They're red now. as opposed to yellow. The yellow ones were triggered. The red ones are our mandatory breaths. So we said that at a rate of 10, our mandatory breaths are going to be delivered with an eye time at a rate of 10 into 66 every 6 seconds. So every 6 seconds, 2 seconds there's one, 8 seconds there's another one. Also pay attention to what's happening right here. That number's coming down. Your total rate is coming down, and it should eventually get down low enough to where it'll match 10 and 10, because now the patient's no longer auto-cycling because we have appropriately addressed our flow trigger. So I will stay here until it drops down to 10 so you know I'm not lying to you, and then we'll conclude this video. There it is. Thank you for your time.